My project is in situ resource utilization of Martian regolith for construction. In situ resource utilization basically just means using the resources already available in situ or in that place, which is really important on Mars because it would be costly and inefficient to have to shuttle materials from Earth. So I've been doing my research on sulfur concrete as a construction material. Regular concrete requires aggregate, which is just crushed rocks, water, and cement. But water is a precious resource, and cement isn't even available on Mars. However, sulfur concrete only requires sulfur and aggregate, in this case the Martian regolith, heated and mixed together. Additionally, regular concrete takes about 28 days to set and longer to reach full strength, but sulfur concrete is at full strength immediately after cooling. In the past, I've done research on how best to create the sulfur concrete, testing strength with different aggregates, with iron added as reinforcement, and I even got to use a UCF lab, a universal testing machine that showed me that sulfur concrete is actually just as strong with compressive strength as high strength Portland concrete, which basically proves that sulfur concrete is a really good viable building material for on Mars. So once I proved this, the next step was to figure out how we could actually build using it. So I decided on additive manufacturing, which is basically the process of 3D printing material layer by layer. And there are actually some companies like Icon and Apiscore that are currently 3D printing regular concrete homes here on Earth. So I designed a system for additive manufacturing on Mars, what I call SAM. So last year I designed my first model of SAM and was able to successfully extrude sulfur concrete along a programmed 20 by 20 centimeter square with control of a gantry system moving in the X, Y, and Z axes. However, my extrusion system, as you can see, was very simple, composed simply of a PVC pipe, sort of like a funnel with tubing coming completely underneath. And this system was relying on gravity, which I knew would not be practical for Mars because there's different gravity, and also it's not a very precise way to control the extrusion process. And also I was having to pour through hot water before I could get the sulfur concrete through, or else it would solidify before it could start to flow. So I wanted to be able to incorporate a more heated system, which would ultimately be necessary on Mars to keep the sulfur concrete workable at sulfur's melting point of 115 degrees Celsius. So this year I incorporated heated taper on the tubing and a heated reservoir, which also allowed me to reuse sulfur concrete between failed trials. And I used a peristaltic pumping system in order to better improve that extrusion method. And peristalsis is a term I learned in biology as the squeezing motion used in the digestive tract. And it's actually used industrially to move really viscous liquids and even solids by positive displacement by creating vacuums. I created the new and improved SAM in a series of stages. First, adding the heated elements with the gravity system from last year, which didn't even work, showing the necessity of this new extrusion system. So then I designed and built the peristaltic pump, incorporated the new system, tested it first with water, then with sulfur concrete, and then I incorporated it with the gantry system and programmed it to successfully print sulfur concrete along a 20 centimeter wall, which was really important and significant because it showed that sulfur concrete was able to build up and the extrusion system with the peristaltic pump was a working system. Building the system was a very iterative process with various difficulties over the course of about 13 trials, but ultimately I was able to create it to be successful, although I did discover some limitations as to the pump's capabilities to pump more optimal, thicker ratios and certain configurations where it was going straight up.
Thanks for watching, and please check out my poster for more information about the process of creating SAM.